Welcome to Pomodoro Joe for Monday, May 22nd, 2023. Today we're doing LeetCode problem 347, top k frequent elements. This is a medium problem. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. All right, this is pretty straightforward. In the example, we've got 3 1s, 2 2s, and 1 3, and the k is 2, so we return 1 and 2 because those are the most frequent elements. We have some constraints down here. It's guaranteed the answer is unique. All right, so we'll put 25 minutes on the Pomodoro timer and we will get started. So this one actually has a ton of different ways you can do it. So I'll just do the first one that comes to my mind, and then I'll show you a one-liner that is a very Python-specific way of solving this problem. Okay, so the first thing that I want to do with this one, I actually want to calculate the frequencies. So Python does have this thing called a counter. I'm not going to use that for this first solution because it's not really generic to other languages. So for this one, I'll just use a dictionary. I will go through and I'll count all of the numbers. So the key will be our number and the value will be its count. So I'm going to use a default dictionary for this. Now we just go through every number in our nums. Okay, so now we have a dictionary where the key is the number and the value will be the frequency of that number. Now we really want to sort these by the frequency, which is the value in our dictionary. So we kind of need to pull that value out. One way we could do this, we could actually invert the dictionary, but I think what I'll do is I'll use this one. Maybe I should do the inverted dictionary. Yeah, I'm going to use an inverted dictionary here. And when I say inverted, I just mean I'm going to flip the keys and values of this dictionary. So the key will be the frequency and the value will be the number. So let's call that inverse. So the idea here is we really want to sort by our frequencies because we want to return the k most frequent. So we really need to sort by frequency. Unfortunately, we don't really have a nice list of our frequencies. So I'm going to invert our dictionary so we get a mapping from the frequency to the numbers, and then we can sort our frequencies, and then we can get the inverse value out. So basically use that frequency to find the numbers that map to it and create our result. It's a little bit confusing, but here we go. So this will also be a default dictionary, but it will be a default dictionary with a default value of a list because the same frequency can have multiple numbers that map to it. All right, so now we can actually go through every key value pair here in our counts.items. So this is something that Python gives you. You can do something similar in most languages, basically get the key value out of your dictionary. So now in our inverse dictionary, we're going to have the value. Maybe I'll change this from key value to be number and frequency so it makes it clear. So that's number and frequency. So now our inverse dictionary will have a key of the frequency and a value of the nums. But this value is actually a list. So we will be appending this num to our list. Okay, so now we have a new dictionary where the frequency is the key and the value will be a list of all the numbers that map to that frequency. So now what we want to do is pull out all of those frequencies, so the keys, into this dictionary and sort them. So let's see here. Okay, so we can use inverse.keys to get all the keys of this inverse dictionary, and we'll use sorted to sort them. Now this is going to be sorting from low to high. And what we really want is from high to low. So we will do reverse equals true. So now we've sorted all of our frequencies from the highest values to the lowest values. And now we have to build our result. So our result will be some list, and we'll return our result at the end. And now we're just going to go through all of our sorted frequencies and start adding them to our result while the result's length is less than k. So while results, let's see, what the length of result is less than k, we still need to add things to our result. So we'll grab something out of our sorted frequency here. Let's see, I guess I'll need to keep track of which index we're at. So let's do this, index equals 0. So our result, we will just extend our result. So the result is a list, and all of our values in our inverse dictionary are also lists. So we'll just extend the result by whatever's in our inverse dictionary. At this key, okay, so we need to grab the key, which is the frequency. Maybe I'll just call it frequency here. And that's going to be our sorted frequencies at this current index. Then we'll grab our result at the inverse at this frequency. So remember, the inverse maps the frequency to a list of numbers that had that frequency. So we'll grab that list of numbers, add it to our result, and then we need to increment our index. And at the very end, our result may have more than k elements because we don't know exactly how many elements we're appending each time. We're not keeping track of that. We just know we have at least k elements. So we'll have to truncate this at k elements. Okay, and this should do it. Let's see how we do. And that works. Let's see if we can pass all the tests. And we pass all the tests. We don't do great though. We only beat 24% for runtime and 41% for memory. So let's jump back and see if we can fix this up a little bit. So one thing we're doing is we're calculating this length every time. That's going to be a little bit expensive. So we could actually just keep a count in here if we wanted, and then keep track of the counts of how many we're adding here. I'm not going to do that. I think this is a little bit confusing. I mean, so this is the way I would solve it if I were just approaching it from scratch. This isn't necessarily the cleanest way to do it or the most intuitive way to do it, but we're basically going through finding the frequencies for all the numbers. Then we're getting an inverse mapping, so we can map from a frequency back to some list of numbers. The only reason why we do that is because we want a list of frequencies that we can sort, so we can find the most frequent elements, and then get back to the numbers by going through that list of frequencies and putting these numbers into our result. All right, so there are other ways we can do this, and I'll show you a couple of them now. So one thing we can do instead of doing all of this, so Python lets you group things together into tuples or lists. So we could actually avoid a lot of this just by grouping things into our lists. So let's see, we've gone through, we've calculated all our frequencies of all the numbers. Now we can actually just create a list of all these frequency to number mappings. That'll be a little bit easier. So we can have this frequency to number mappings. What do I call this actually? So the goal for this part is we're going to couple these frequencies to their numbers and put them in a list. Then we'll sort that list by the frequencies. So maybe I'll call it the frequency to number map. It's actually going to be a list. And then for every, let's see, we're going to have a key value pair. So again, we'll call it num and frequency in our counter here, counts.items. So for every number frequency in our count items, we're actually just going to throw that as a pair into our frequency to number list here. And I'm going to make this a tuple, and we're going to do frequency and num. So this way when we sort, it'll sort by the first value first, our frequency, and then num second. One thing we could do at this point is to use the negative frequency so that when we do the sort, we don't have to reverse our sort. I don't actually think it's going to make a huge difference either way, so we'll just keep it as our regular frequency. Next, we want to sort this. So our result, let's see, we'll call this sorted frequency to num. Or actually, we'll just sort it. We don't need to call it anything, so. So we're going to be sorting our frequency to num. Now, in Python, it will do a default sort by sorting by the first value first and then the second value second. If you're doing this in a different language, you might need a custom comparator for this. All right, so we're going to sort, and we actually do want to reverse and set that to true. So it's going to sort from the highest frequency to the lowest frequency. Now we have to convert these tuples into just a list of regular numbers. So our result here, well, that's going to be a list, And we're going to take the second part of our element, so we'll call this E for element, and we'll take the number part, so that's element index 1, for every element in our frequency to num sort. Okay, so we take our element for every element in our frequency to num, and we're going to grab the second piece of that, or element index 1, and that's just going to be our number. We're going to put that into a list for our result. We could actually make this a little bit faster by only going through the first k elements here. And then I don't think we actually need this limiting factor here. Let's try that. I need my in. Got to put the in there. Let's do this. All right, that still works. Let's see how this goes. A little bit shorter, a little bit easier to understand. And we do much better. We get we get an 88% for runtime and a 30% for memory. That is way better than our 24% for runtime. All right, so these are two different ways we can solve this problem. The basics are breaking this down into counting the frequencies, then sorting the frequencies somehow. You can use lists like I did here. You can use heaps, which actually would probably be faster. You can use whatever method you want to sort just the first k elements and then return your result as a list of those elements. Now, as promised, I will show you a one-liner. So we can use Python's built-in counter. So we can use the counter class, counter for nums, and I believe it is common, most common, that's it. Most common k. Now this counter doesn't just return the most common k as a list, so it will return this special data type for counters. So we actually have to go through and grab all the data out of it. So this will be for every element at index 0, for every element in our counter of nums most common k. And we wrap that whole thing in a list, and then we can just return that. I think I got this right. Let me just run it and see what happens here. That works. All right, we'll submit that and see how we do. And we pass. So this is a one-liner. We use some custom Python things. We use this counter. It has this most common k, so it's kind of cheating because that's exactly what this is asking us to do. But it works. And we get a 43% for runtime and a 41% for memory. So it's not bad. We still did better with our own list here though, with this, let's see, 88.14% for runtime. So yeah, sometimes it pays to build your own. Usually it doesn't though, so I wouldn't recommend it. All right, that is it for me. There's a ton of different ways to solve this one. I recommend you try it, check it out, try your own thing, try using heaps. It's fun, it's a good way to do this. So yeah, that's it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.